This is Scott Jercich. This is a demonstration of individual Project 3, the Neopixel Pong game. Here you will see I have an Arduino Uno, a breadboard, an addressable LED strip, wiring, and a battery all mounted on a piece of cardboard. Now the breadboard contains two push buttons. The one on the left is for player A and the one on the right is for player B. And next to each button is an LED. The left LED is red and the right LED is blue. And in the middle you'll see we have a potentiometer which controls the speed of the game. Looking at the addressable LEDs, you'll notice that there are 8 LEDs. Now the specification for this game requires that the game to have a beginning and an ending animation. So as you'll see when I power up the project, that the 4 left LEDs of the strip will blink in red, signaling that player A is on the red team, and the 4 LEDs on the right will blink in blue, signaling that player B is in the blue team. Now this red and blue theme of the startup animation ends with the red LED player, with the red LED near player button A, and the blue LED near player button B blinking twice. And after that double blink, the players know that they can begin the game again. Now the way this game works is that one player pushes his button, which sends a speeding LED down the strip towards the opponent's end. The opposing player must then push their button before this LED reaches their end. If they don't, they lose the game. Now the source code registers each individual button press, and as such, one player cannot gain an advantage by simply smashing down their button for the entire game. Also, each time a player pushes their button, their LED will light. So if a player plays with a strategy that they just rapid fire their button, the opposing player will see that that's happening. Now for demonstration purposes, I've set the potentiometer to its lowest level so that we can see how the game works in slow motion. So I'm going to plug it in and we'll see the beginning animation. So blinking lights, red and blue, and then at the very end, these LEDs blink twice. So that indicates the game can begin. Now first I'll press player A's button and not press player B's button. This should result in player A's LED coming to the end at player B's end, and player A should win. Now when player A wins, you'll notice that the 4 LEDs on player A's side will flash in red, indicating player A has won. And the same thing will occur when I push button for player B, and without an answer from player A, then player B will win, and then player B's 4 LEDs will flash in blue. So let me demonstrate that now. I'm pushing player A's button. You can see the red LED is proceeding down to the end. Boom, player A wins, and the 4 LEDs on the left-hand side blink. Now you can see the game is resetting itself. 2 blinks here means the game can start again. This time I'll press player B's button without an answer from player A, and you can see B's blue LEDs marching down to the end. When it reaches the end, player B wins. There's flashing blue lights, and then the game resets itself. So I'll now play a little bit back and forth so we can see how that will work. So I'm pressing player A's button. You can see the LED is proceeding down the end. I'm going to press player B's button. Now player B's LEDs are going down to the other end. I press player A's button, then player B's button. All right, and let's just say that I press it one more time, and let's say the game's going quickly. Player B doesn't respond, so player A wins. The winning animation, reset, and both LEDs will blink here twice, indicating the game can begin again. So as you can see, the game seems to be working as expected. Now, as a final note, with earlier versions of the game, I noticed that after one player would win, the final button press of the losing player caused their LED to remain in play and proceed down the winning player's end of the strip. Now, this is not ideal. This is not what's desired. So to resolve this problem, I ran a wire from the reset pin of the Arduino to digital pin 12, and I wrote code that holds digital pin 12 high. But at the end of the game, pin 12 is set to low, which is equivalent to pushing the reset button on the Arduino Uno. When this happens, it kills all code. Any residual LEDs proceeding down the strip from the losing player is terminated. Then the game resets itself, there's beginning animation, and the players are ready to begin again. So this concludes my presentation on individual project 3.